So hello everyone and welcome to this next session. So in this section, we will get started with a real world data set. So we're going to pick one out from Kaggle. So just the thing, last time we got cut off abruptly because the time limit is 40 minutes on this basic Zoom account. So in the future, we will keep in mind that when we are close to 40 minutes, we will probably get disconnected. So we started at around 3:58. So we will end at around 4:38, right? So the time is almost 4 p.m. So before I start, as usual, a quick question. Does anyone have any doubts so far about what we did? Well, not much, I guess. So what I'm going to do is, just in the previous lecture, we actually created some random data frames and we just played around with them. That is, in the sense, we created some columns, created some rows, extracted a few elements and things like that. So we could continue with this, but things will be much more interesting if we actually take a proper data set. So for that reason, let me go over to my Kaggle. Now, in Kaggle, there are a lot of data sets you can actually search through. So for example, you can just browse through data sets. There are many, many. But I thought to get started with, a good one is video game sales. Right? The reason is it's not a very large data set, so it's quite easy to deal with. It won't take away too much of a computer's resources, and at the same time, it is a decent enough data set that we can do some amount of computation with. So the way it is when you get a data set, it's usually like this, and you can actually go and look through several of them. So some people just upload data sets, some people actually put a task and say that this is what I want, and it's like a challenge, so you can solve it. You can go through the description and see what it is about. So for example, this data set contains video games with sales greater than 100,000, and they generated by scraping this website. So you can do a scrape using Beautiful Soup, using Python. And there are these ranks, these are the columns in the data set, right? So this is a screenshot of the data set. Now what we're going to do is, let us download it. So it has downloaded. I'll go over to my file browser. Usually it will download in the downloads folder, and that's where this is. So I'm going to cut this out, go to my Learn Python, create a new folder called datasets, and paste it here. So let me extract it. This is what I get. So when you extract it, there are different ways in which you will get a dataset. For example, you might get a dataset in this format, which is called .csv. CSV stands for comma separated value file, right? So for example, you can open it with any spreadsheet software. So most of you will be using Windows. You can use it, you can open it using Microsoft Excel. In my case, since I'm using Linux, I use LibreOffice Calc, but it's pretty much the same thing. So
someone has an issue downloading the dataset.
Okay, then can you just tell me what it is? I don't monitor the chat. You will have to download, by the way. You will have to.
So the thing is, when I click download, it just takes me to another, let's say, page, and then it doesn't do anything.
Oh, are you logged in?
Facing this. Yeah, I'm logged in.
If you're logged in, that should not happen.
Actually, face this over two browsers. That's why I'm not able to understand what's going on.
Which browser are you using?
I tried with Chrome and Firefox.
I'm sorry. Okay. I can't think of why you should not have it. Again, I think maybe just check if you're down. What do you see? What do you see when it redirects you?
Nothing. The page is just blank.
I can't make out what it is because unless there is something that your Windows is blocking you, there is nothing. I mean, this is it. You just download it. It just downloads the CSV file. That's all. So I don't see.
All right. It's all right. I
because-
don't want to hang up the class. I'll
Yeah,
figure
yeah,
that
sure.
out. Thank you.
Yeah, okay. Because there's nothing to it other than that. So if you see a CSV file is something like this, it's just like any other Excel sheet. And you can look at it like an Excel sheet also. So you will be able to, if you see it in Windows, it'll also look exactly the same, right? Now, the reason why this is called an Excel sheet, and I'll just close this down for a minute, is that it actually, under the hood, you can open it with even a normal text editor like Notepad, or in my case, I'm using gedit, which is the equivalent of Notepad. And when you see, this is the actual file, right? This is the actual file under the hood. And you see why it is called a comma separated value file. You see, these are all values which are strings or can be anything, number, string, anything, separated by commas. So every time you see a comma, that means it is another column. So these are all columns separated by commas, right? So this is what it really is. Right? Now, the reason why comma separated value files are really useful is because they are actually just text files. So you can read them like any text file. You can read them even with just basic file reader. And at the same time, you can also open it in a spreadsheet software. So you can have the best of both worlds. Okay, so here again, I'll just pause for a minute. Does anyone have any doubts? I do understand there was one problem with downloading, but does anyone else have any other issue? Okay, so now that there is nothing much, I will get started with how we can read it. So the first thing we need to do is, as always, let us import numpy as np, import pandas as pd. Right? So these imports always have to be done because I open this, whenever you open this browser, it is actually a blank workspace. So you have to run the import commands again to get the packages again. Okay? So now that we've done this, we are trying to get, let's give it a better name. Let's say viddf. We use the PD package. Now before we were creating a data frame, right? In the previous lectures, we created a data frame. Now we don't have to create a data frame. We have to read a file, right? Now, in this case, we are reading a CSV file. So we use the read CSV method, right? Now, let's look into the help of this to see what it is. The read CSV method has lots and lots of parameters. And during the course of these lectures, we'll see what these different parameters are. But the most important is the file along with the path. And that's what I'm going to talk about soon. The separator by default is a comma. Right? Because we are talking about CSV files. As I said before, CSV, the name itself means it's a comma separated value file. So therefore, the separator means it's a comma. But if for some reason this has changed, let's say it becomes a semicolon, then you can use this argument to override the separator and specify something else. Right? But rarely is it ever used. But if you need to, this is there for you. Others are delimiter and several others. So we'll look into this as time goes on because we will be looking at several data sheets. So in the meantime, what we have to look at is the file path. So to specify the file path, we have to use just a quotes because it's always you're passing in a string. Now, if you go to a file browser, actually the file browser, this is where I am. This is where my Jupyter notebook is, right? Untitled IPython notebook. Within that, I have a file. Within that, I have a folder called datasets. And within that, I have another one called video game sales. So I need to migrate two folders. So let me do that. So first, I need to say datasets, and it will complete it. After that comes video game sales. So it offers some tips. And then finally, VG sales. All right. So this is the entire path of the file. So this is the file along with the path of where you are. So Of course, you can navigate to anything you want, but my recommendation is try to keep it as close to your Python file as possible so that you don't have to go too far down or too far up the directory string. So let me run this and let's see what we get. And this is our data set. So you see there are almost 16,600 columns, 600 rows rather, and therefore it has cut it off like this with these dots, because see what it's trying to say is it's showing the first 5 and the last 5 and then saying there's something else in between, and it shows you most of the columns, right? So this is pretty much the data set which we also saw in the spreadsheet software. So at this point of time, I will take a break and I'll ask, does anyone have any doubts so far? Okay, so now that we are here, the next thing which you can do is there are several basic commands that you can run to know what kind of data set you have. So for example, you can say with df info. Okay? The info method is available with every data frame and it gives you information about your data frame. So for example, it tells you what kind of an object it is. It tells you it's a data frame object. It tells you what is the index, right? And the index is basically a range object with 16,598 entries. So it starts with 0, goes all the way up to 16,597. This is your index. What are the columns? Now these are the columns, right? Don't mix this up with the index. This is the column. These are the names of the columns. These are all the different columns that you will also see here, right? And this tells you how many values a particular column has. This is very important, all right? For example, it tells you that these are the number of non-null entries in this column rank. So for example, if you see, since I have 16,598 entries, some of them have all the values fully entered. Whereas there are some where there are not fully entered. For example, here, the total number is 16,598, but the number of non-null entries is 16,327. What that means is we have some entries missing. And that is quite often the case because when you're collecting data, people do not always enter every data. Sometimes data is always missing, right? So, and of course, a few more types. For example, what are the different types? Most of them are float 64. A few of them are int 64. And then there are some which are objects. And objects typically means it's a string, correct? So once again, I'll take a quick pause. Does anyone have any doubts so far? Okay, so the next very useful commands, or rather the next couple of useful commands are what is called head. Head gives you the number of the first 5 rows of a data frame. And sometimes this is very useful when you want just to know what is the structure of your data frame, like how many columns do you have, what are the kind of data they have, for example, how many of them are numbers, how many of them are strings, what are the contents. So this is a very useful way. Of course, you need not, if you do not specify an argument, it will give you 5. But you can always go and specify an argument. So for example, I can say 10. And this will give me the first 10 rows. And in exactly the way you can get the first 5 or the first 10, you can also get the last 5, saying till. So these are the last 5. And in the same way, you can also give an argument and you can find out what are the last 10 or so rows in a data frame, right? So once again, I'll take a quick pause. Does anyone have any doubts so far? Okay, so since we are here, the next question is, now I'd like to hear from you guys, what would you like to do with this data? Now, this is very important because when you're getting into data science, quite often you'll be given data. Sometimes you're given a specific question that they want to solve, right? Sometimes. And sometimes a lot of people have data and they don't know what to do with it. This is quite often the case. For example, when I go meet people, they say that, oh, we are running a startup, we have a lot of data, but we don't know what to do with it. So quite often you'll get data, but there is no goal or agenda given. So you got to figure out, okay, let's say in this data, what do I want to do? So I'd like to open this out to you guys and you tell me, what do you think we should do? And let's slowly learn the Panda commands to be able to achieve that.
Can we see what are the factors on which the sales depends?
The factors. Now, when you mean factors, what exactly do you mean?
Can we do some basic visual analysis of how sales performs according to some parameters? Let's say sales versus year, something like that for a particular.
Yeah, that's a good idea. So like, for example, so now first question is, let's go write that down so that we know what our goal is. So what we are trying to do is, let's lay a challenge. Find out how sales varies with year and any other factor. All right. So this is it. Great. So now that we have a particular goal in mind, first, always the best thing to do is look at the head. Right? So we have this much. Where are our sales? Now we have several sales. All right. For example, if you look at, and you can look maybe even at Kaggle if you want, but this is the actual description of how it is. For example, there is a North American sales, there is a European sales, there is Japan sales, and there's sales in other parts of the world, which are not these. And then there's total worldwide sales, right? So we have several factors of sales. So let's start talking about some of the sales. So first thing we can do is, you want to know how sales varies with year. So let's go and pick out this year column. As I said before, if you want to pick out a year, you just have to use the square brackets. Always remember, the square brackets, it's similar to NumPy or anything else. You always have to extract something with square brackets. So let's say we have year. What do we get? Oh, sorry. This is not, it's with df. With df. So this is what we get. Right. So now the first question you can ask is, they are not ordered in any way. It's quite obvious. You see, it starts at 2006, goes to 1985, you see 2010, you see all kinds of things. So now the first question you can ask is, what is the lowest value and what is the largest value? So where does this data set start from? Which is when was the year when it started collecting, right? Now, to do that, all we have to do, now I'm just going to copy all the commands because then I can give you the data set, you can use it later. The way to do this is, you say min. Min is a method that you can apply on any pandas column. All right, it'll give you the minimum value of that column. So for example, if I say with df year min, the lowest value is 1980. What that means is, this collection of data started at the year 1980. Along with that, let us find out the other one, max. And the max is 2020. So this is a very recent data set. So we have the collection of video game sales over 40 years, right? 1980 to 1920. So that's our first question. So once again, I'll take a pause. Does anyone have any doubts about what I did so far? No doubts? Okay, so I'll continue. So let's say first and foremost, let's just go to the global sales, right? You can look, we'll start looking at different things, not a problem. But let's start with the total sales all over the year. So you can always press tab to do auto completion. So as before, let's look at this. Now this is always in millions, right? So you can go to Kaggle and check out. The sales is always in millions, I guess millions of dollars, right? So, or maybe even millions of copies, doesn't really matter. Could be millions of copies actually, because nothing has been spread in terms of currency. So now here you see there seems to be some kind of ordering. So for example, if you see, it's all in decreasing order, 82.74 and goes all the way up to 0.01. So now the next question you could ask is this really the case? And the best way to know is we can always run these two commands again. That is, let's do min. The min is 0.01 and let's do max. And the max is 82.74. So our initial surmise that these sales are organized in descending order seems to be correct. All right, at least for now, because we have so many, these are in descending order and these are all equal. So we have been able to calculate what is the maximum, the minimum sales, what is the minimum and the maximum year of this data set. All right. So once again, I'll take a pause. Does anyone have any doubts so far? Okay. So now that we're here, the next question you could ask is, first, let's find out who is this maximum person. All right. Now, in this case, it's pretty obvious that it's this first one, but can I get this number through a query? Because remember, you do not want to be using visual, you do not want to visually see anything in order to decipher a result, right? In a data frame. Always remember, whenever you want to answer a question, you should always use a query like this, all right, or a method or a function. Do not look at the data and try to find out inferences, because that's prone to error because you're using your own inference, right? So now how will I do that? Now the question is this. The question is, who is the game, or rather not, which is the game that had the maximum global sales? All right. How will I do that? I will do that using a query. First and foremost, I'll break this up, and this is a little tricky. So we're going to go through it bit by bit. So let's say I want global sales, right? Now, if I type this global sales, if I just press enter now, I'll get the column. We already have that, so there's nothing new. Now the question is, we want to know which rather row or whichever game had this global sales value equal to this maximum value, right? That's what I want to find out. So how will I do that? I do it using a query like this. I just have to say, what is video DF global sales equal to the maximum value? Now the question is, does anyone know what will come if I execute this query? This query is not what we want, and that's the reason, and that's why I'm going a little slow with this. If I execute this query, this will give me a series. This will not give me the actual row that I want. This will give me a series. But this series will actually lead to the answer. So I'm going to press enter and tell you what this is. So you see what you get here. You are getting a series. Okay, this is a series. You have the indices, you have data. Now, the data is Boolean, right? Data type bool. And this bool will be value true when this query is true. And it will be false when this query is false. All right. So when you run this query, you're getting a series of the same length as the data frame, so the same number of rows, but you will get, this will be true for all those rows in which this query is true. And it will be false for all those rows in which this query is false. So therefore, if you look from our inference, we know that the global sales is arranged in descending order. Therefore, because we are looking for the maximum value, only the first row is true, all other rows are false. So here I'm going to take a break. Does anyone have any doubts about what I did?
Yeah, so here, like most of the rows in the middle are hidden.
Yeah.
And if one of them turns out to be true, is there a way to find it out? Because
Yeah.
here we are able to see it.
Yeah, the reason, the best way to do this is to find out, now, like I said, this is not much use, right? Because all we're getting is true and false. So if I want to find out the actual rows which is true, what do? I have to say video df. I have to use this square bracket notation. Now, usually I can specify something like global sales. I can specify a column name. But there is another way also. Within the square brackets, you can pass a query that results in a series, right? So I can pass this series in. What that means is I can pass this query in within the square brackets, right? Now, this is something which is very difficult to understand in the beginning, and it also frustrated me a lot, but you can do this. When you do this, that is when you pass a series of booleans, true and false, within the square brackets to a data frame, it will return back all those rows for which the series is true. So now the question is, again, I'll stop for a minute. Does anyone have any doubt? And I think this might also answer your question.
Yeah, thank you.
Any other doubt? This is a little tricky, so if you have any doubts, please do ask.
Can you please repeat in a brief?
Yeah, so what it is like this. If you want to do a query, when I mean a query is you are asking a question from the data frame. So here I'm asking the question, which values of global sales were equal to the maximum value? This is the question I'm asking, okay? Now, when you ask such a question in such a manner, you get the result as a series, all right? The series will have the same length, the same number of rows as the entire data frame. It will have the value true when this query is true, and when it will have the value false when the query is false. All right. So this is the result of such a query. Now, if I want to extract which row is actually true and which row, only those rows which are true, then all I have to do is pass this query within the square brackets, and it will give me back the row for which the query is true. Does this answer your question?
Yeah.
Any other doubt? So let's go and let's play a little more with this. Now the question is, besides the mean and the max, what else can I find? Actually, there are lots of things. For example, if I say with df global sales, now to this I can apply several methods. So you see, these are all the methods that I can apply. And you can also create your own custom method which I'll talk about very soon. So you see, these are all of them. There's several ones. You can actually either explore, or as you go on, once we go on, we'll see what all we can do. But another one which we can do is the mean. So what is the mean sales that was there, right? And the mean sales is this 0.5374. All right. Now look at what it is. This is very interesting. Do you see? And I would like if anybody comments on this. And this is very important in data science, right? Because quite often you're given some data and you're looking at it for the first time, and you have to sort of feel your way through the data to try to figure out what it is, right? It's like a detective almost. So now you see, can anyone tell me what is the significance of this value? To know the significance of this value, compare it with the maximum value. The maximum value is 82.74 million, right? So this one game, that is WII Sports, right, sold 82.74 million copies all over the world, right? And the mean global sales is only 0.53 million. So it's like 537,000. So look at the difference between the maximum and the mean. Look at the difference. There is a huge difference. What this means is that actually most video games don't really do that well. Only a few games really do so well as to sell millions and millions of copies. A large amount of the games will just sell a few 100,000 copies. That's it. That is the significance of this number. Anyone has any doubts about this? I would strongly encourage you to keep asking doubts and feeling your way through, because like I said, this is really data science. And this is one of the reasons why data science is a bit complicated, because quite often you're given data and you're like, you don't know where to start, right? So feel free to ask.
Yeah, Shivakumar, will you please repeat this mean function again?
No, mean will just take the mean value of a particular column. That's it. It's the average. You can also say it's the average. So for example, mean is better because it's more mathematically correct, but I think average also exists. Let me just try. No, average doesn't exist. Sorry. So you have to use mean. So basically mean is the arithmetic mean. So it's just the sum of all of them divided by the total number.
Okay. Thank you.
Any other doubt? So now, just before I have only around a few minutes left. Now, I'm going to do one more calculation. What if I want to find out how many games have sold more copies than the mean? All right. So which means how many games are doing at least better than average? Okay. So now, does anyone have any doubt about what I just said? This is quite often a normal thing, because you want to say, okay, let's say, who's better than the average? So how will I do that? As before, we take the column. Now we'll have to run a query. What that means is we now have to say greater than, we can say greater than equal to, and let us put this mean. So what we are doing is we are saying how many of these global sales, how many entries in this global sales is greater than the mean value in global sales. That's what I'm saying. As before, if I execute this, I will get back a series. That's it. So you have a few true. Now you see, before we were getting only one true value. Now there are several truths. To know better, as I said, all we have to do is put this within this square bracket. So if I pass this query within these square brackets, it will give back all those rows for which this query is true. And you see, these are all those queries. Look at it, 3,756 rows. So check out what we get. Out of 16,598 games, only 3,756 games performed better than average. Does anyone have any doubts here?
Can you save this as a different data set?
Oh yeah, sure. So you just have to say, like, for example, if I want, I'll just copy this. Just say above average is equal to, and this above average is my new data frame. That's it.
Yeah, thank you.
Any other doubts? We are almost running out of time. So once again, if you can ask your question, but you might get cut off. So by all means, go ahead. Okay, so I think we are almost out of time, and I think we should stop rather than try to do something new and then be broken off halfway. So as before, tomorrow there will not be a lecture because, like I said, it is Quiet Sunday in Germany and I cannot record or speak loudly. So the next lecture will be on Monday 4 p.m. And as before, I will post both the YouTube link for this video as well as send you the link for the Zoom meeting, which will be done tomorrow. And once again, I have created a Google group and I have been posting a Google form on my LinkedIn for being able to join the Google groups. So please do add your email to the Google form and I'll send you an invite to the Google group. So this way, at least we can have more discussions offline. So I guess we are pretty much out of time. If anyone has any ending comment, I'll be happy to take it. Otherwise, we will wind up this session.
Yeah, just let us know the data set on which we are trying to work so that we can download it and keep it.
I already said,
having-
actually check out my LinkedIn. In the LinkedIn, I have put a data set where I put the link for that. Actually, there were two posts. I think the first, there was a problem with LinkedIn and it didn't show up and I thought they deleted the post for some reason. So then I put another one. But I will, and you can, and also send the data set link in the Google group. So if you are a part of the Google groups, you should have got an email with the link for the data set.
Okay, I can see it. Thanks.
So I guess we are out of time. If anyone has anything, please do add.
How to access the Google groups?
Oh no, just just go to my LinkedIn. In any of my posts, I have set up a Google form. So just add your email to the Google form and submit it. I will get it and I will just send out invites to everyone.
Okay, I have filled that form.
Yeah, I think then you might have got an invite because I think I just sent out like 12 invites today.
Yeah, sure, thank you.
Okay, any last doubt before this meeting is automatically ended? Okay, in that case, I will at least try to end it normally by saying, okay, goodbye everyone. Have a nice Sunday and hope I can see you guys on Monday at 4 p.m. I'll send the Zoom link tomorrow for the YouTube, for the meeting.
Bye. Thank you. Bye.
Thank you. Happy weekend.
Bye everyone.
Thank you, sir. So today's lecture was really interesting.
Yeah, it will get more interesting once we get the data sets.
Yes. Thank you, sir.
Okay. Yeah, bye everyone.